Our next two presenters, participants, need no introduction, so we're not going to give them one. Asya and Danielle, thank you so much. It's Ask Them Anything, ATA, AMA, and I'm here to run the microphone around. So raise your hands and I'll come find you. Anything goes. Fire away. These are two of our best and brightest, so very excited to hear what they have to say.
Now, and even though the topic says schema design, feel free to, expand the range of questions if you want, anything MongoDB related, or even not. Ask us what the weather's going to be next week. We'll just make something up.
Asya, since you extended your offer beyond
I did.
I will ask you. So in Atlas services, for functions, they can be, the triggers can process either serially or parallelized, right, depending. If they are processed in parallel, how many of them will process in parallel? Is there a limit? What is that limit?
Do you know?
How often does that number change?
We don't know.
Not a problem, not a problem. I will give this to somebody else.
We
but
have some Ask the Experts over
They
there.
didn't know
Maybe
either.
They didn't know
No.
either? Oh, did they know where to look it up?
No.
Because I know where to look it up. I just don't want to
Yeah,
be
no
looking it
problem.
up now as we're, waiting and stuff. Find me at happy hour. We'll look it up together.
Awesome. Great question.
Yeah, great question.
If you have a question that Asya cannot answer, that's a great question.
I
Next.
can always make up an answer because the limit is arbitrary, right? It's whatever we set it at, right? So it's a matter of either finding it in our internal docs or code, because I assume you checked the external docs yourself.
It's probably the code.
You
so,
probably didn't put it in there,
yeah.
but it's in the code.
Yeah.
It's got to be in the code.
Next
Questions?
question.
Anything. You're just here to find
Yeah.
out about what other people want to know. Go for it.
Nobody else
just
wants
just
to,
leave
yeah.
them with the mic
Yeah,
until
absolutely.
somebody else reads it.
So also for Atlas services, for the logging, even if you connect to logs using the Realm CLI, the logs take like 3 to 5 seconds to appear. Is that by design? Is there some like limitation around that? Is there any way to get them to appear in real time?
Why?
Why in real time? Well, I mean, as you're sort of watching and you're trying to debug, 3 to 5 seconds is kind of a delay.
Yeah, I'm guessing no, because they go to a centralized place and then they need to be fetched from that. So my guess is it's just not a thing that is super important to optimize. So it's probably optimized for reliability, not speed.
And not speed.
Yeah.
Okay.
I mean, feel free to file that as a feedback thing
Okay.
that would be important, because nobody's going to prioritize for speed if they don't think it matters to the end user.
Sure. And then a follow-up to that, as far as trigger processing, triggers also are processed with a delay.
Using triggers.
Yeah, of about 2 seconds. Do you know why? Is that just some back-end limitation?
2 seconds after the
After the
request goes
collection
in.
changes?
Oh, after the collection
After the
change. Well, yeah,
collection changes.
that has to do with the fact that, and this is an attribute of change streams, which is the underlying mechanism that's used by triggers, which is change streams guarantees no rollbacks. What that means is that it will only notify you of events that are majority committed.
That makes sense.
And now, if you have a replica set, that's not that much of a delay, right? That's essentially the latency of the majority of the nodes acknowledging it. But imagine you have a sharded cluster, and you now also get the guarantee that you will get the events in order, which means you have to check that no event has happened on any cluster before you return an event from a particular replica set, right?
Sure.
And so, yeah, inherently it ends up adding, being a few seconds because of that, because of the guarantees that it offers and correctness.
Sure.
Yeah,
That makes sense. Thank you.
yeah, sure. Anybody go to the schema design talk this morning? Oh, there's a
Yes.
question all the way over there. You're going to get a workout?
Well, I'm running over there and burning off the
Yeah.
trail mix. You mentioned about submitting feedback. Do you just want to give a nod to where that
Oh.
happens?
I think if you point at that QR code.
Well, that's for the event, but
No,
if
for-
like
Oh,
a feature.
You mean like for
Request
a
for
feature?
enhancement on the
Yeah,
server or any kind
user
of the
voice.
product.
Yeah, it's feedback.mongodb.com. It looks kind of like forum-ish, because I think you could submit something and then other people can vote on it. Or you can see if somebody else has already mentioned it and then just vote it up. All right, there's a question over there.
Hi, I'm curious how you would implement a folder structure on top of elements. Let's say you have a collection with millions of elements, and now let's say they need to be structured in a folder hierarchy. I'm curious how you would make a schema for a folder hierarchy on top of millions of items.
So, so the question is, how would you model a folder hierarchy? So let's say that each item represents either a file or a folder, and it's like your file system, right? Or, a hierarchy could be catalog, like categories in an e-commerce type system or something. I will tell you that just like with anything else with MongoDB, the answer starts with it depends, right? And you probably already know that one of the things it depends on is how you will be using that data, how you'll be querying it, and how you'll be updating it. Because if it's the type of scenario where the hierarchy doesn't change, like you might add new folders to the leaf nodes, or you might move individual items from one folder to another, that's one use case. But a different use case might be where an entire substructure maybe needs to move somewhere else in the hierarchy. Although you do have transactions, so if it's multiple write operations, you just wrap them in a multi-document transaction. But I mean, my instinct is I would start mentally with, each item has a parent or an array of children or both, right? And then see, does that satisfy what I need to do?
Yeah, in the M320 class, we do have a section where we talk about representation of trees, and that's basically what you're trying to do here. And it goes to, are you going to use it, as Asya said? Because are you willing to pay the price if you have a lot of modification moving nodes around or not? And there's different ways you can model the tree. You can model having the parent, so that's the easier one to manage because you just have to change the parent and the node will reappear somewhere. You can represent the children of a node. And another thing that we've used often in some of our model is representing the ancestor lineage, because that gets you easily getting everything under one tree, all the children, grandchildren, and all that. So you would build all the ancestors up to the root node, and then you could index that.
It also gets you, if this represents a file, the full path to the file. If it represents a product category, then the breadcrumbs, how did you navigate down to that category, subcategory, subcategory, right? So depending on which elements you need to get like super fast, you would want to materialize them either inside the document or have them efficiently indexed to be able to make a simple query to get that.
Yeah, some of these representations will get you the information right away through the index, including the full path. And some representation will require to use the dollar lookup, the dollar graph lookup in order to walk up.
Which is not going to be fast,
Yeah.
but there may
Easier
be
to
reasons,
maintain.
right? May be easier to maintain, exactly. Good question. We have another question. See, talking about this stuff reminds people of their questions.
Hello, my name is Umer. I want to ask that, I was in a demonstration, in a presentation where they talked about changing the schema. All you have to do is you specify the version, number in the JSON document. So is there, is it okay to change the schema, every now and then? Or, are there any best practices, around that? Because, when you're building a prototype, you just start with something really, minimal viable, and then essentially as you progress, as you grow, you change, you incorporate more entities and more fields. So yeah, if you speak to that, that'd be good.
Well, what you're referring to is what we named the schema versioning pattern. Now, we use that versioning for changes that are substantial. In your application, you're going to have to handle things very differently. You may have a different relationship between stuff for a transitional period. When you just have little fields that you're adding, it's add this document, and now, there's a new thing, and we're going to put this new field inside the document. You don't need a version for that. Your code should easily be saying if the field is there, I'll do that. If the field's not there, you don't really, you're not going to remove the code, add and remove code in order to make the transition. So yes, you should do as many modifications as you need to do it, but obviously some will be a bit more complex and will have a cost associated to it. So it's for you to manage.
I mean, it really should be no different than, you know, if you're using some object-oriented, strongly typed language, right? And you have some Java class, and you go, oh, I need another attribute in this class for this object, right? Well, that attribute now gets persisted into the document that represents the object. It shouldn't be any harder than that. If it is, it's because you're refactoring everything about your class hierarchy, and then it's like, oh, yeah, I should probably be persisting things differently as well, right? Good question. We got question on the aisle, question in the front. Now they're going to fight over the mic.
We're on the aisle. Go ahead and hit the aisle first.
More efficient. That's all right. He can use more exercise. He said he wanted to work off the lunch or the future beers. We're very sensitive that all that stands between you and happy hour is us. So we're going to try to talk fast.
So a question about serverless schema design.
Uh-huh.
So if you want to have a choice between 10 collections in 10 different instances, so each serverless instance having one collection versus one serverless instance with 10 collection. Cost-wise, price-wise, there is no difference. So why would someone decide one way or the other?
You know, to start with, I'm going to remove the word serverless from your question, because I think that this can be a question we have hosted on-prem, right, on my laptop, on the production server that my own department maintains. The question is really, if I have 10 things that I'm persisting, should I store them in 10 different clusters, 10 different collections in the same cluster, one collection on the same cluster, right? Like, how do you decide how to separate your data? And I mean, to me, it's kind of like, you know, microservices, right? Why do we decide to separate functionality into microservices? Well, you know, certain independence from, you know, one functionality, one thing of another thing. Well, it should be the same for data, probably, right? Just gut thinking is data that's different, that is in different collections. There's probably benefit in putting it into different instances. What if you need one and not the other? Why bother, right, having it kind of, you know, wake up as far as like serverless goes. But also, when you're building a complex system, like I'm thinking of Socialite, which was like a social platform implementation we did quite a few years ago. And we set it up so that the user stuff is in a separate cluster from the content, which is in a separate cluster from the data feed. Why is that? Well, it's so that they can scale differently, right? One of them might need more IOPS, but doesn't need much CPU or RAM. The other one needs a lot of RAM, but doesn't need very expensive or fast disk. It's very easy to scale them differently. Plus, it allows you to take the one that, let's say, needs lots of RAM and doesn't need much, just going to go, oh, I'm just going to move that into some in-memory thing, right? Or into a different even data store, God forbid, right? But the point is that the more you keep these things separate, the easier it is to monitor, right, which resources each one is using, as opposed to having them all together and then going, we have a lot of disk IOPS, what's using that up? We don't show it to you by collection, at least not very easily. So yeah, keeping things separate would help with monitoring. Can you think of other compelling?
Yes, I will just add a little bit of context. This is valid. I think everyone here hopefully see that all these collections were kind of big and they all have requirements. If your things are small, really put them together. But when they're big and then they may grow differently in the future, that's certainly a consideration. Now, the other thing is if you're going to use the data together, you want to be able to do some dollar lookup on it or
don't
whatever,
use dollar lookup.
then you will need to put them together in the same database at least.
But that's true. That's true. It does have an advantage of being able to, essentially combine the data more easily from a single pipeline or something. No, but we just showed how you can do a federated query. They don't have to be in the same
Yeah,
cluster
It's
even
still
to be,
easy.
to
It's still
be
easier to
combinable,
manage.
yeah.
Now, Asya said, don't use $lookup. It is like a very important thing here that people should know. $lookup is expensive. It's doing a join. It's back to Rick's presentation this morning. This is expensive. Now, we're not saying don't do a $lookup all the time. What we're saying is like the important queries for which it's important to run them fast, you should not be doing $lookup. Especially if every time you pull A, you pull a corresponding part in B. Those things have to go together.
Right.
Now, if you have a query that's not sensitive to performance, then go and you run it once in a while. You can do your $lookup on that.
Or if it's a query that combines data from multiple sources and then materializes the result into a dashboard, right, that people query directly. People care that what they query when they're waiting is super fast. They don't care if it takes 5 seconds to generate that, right, or even 15 seconds, as long as they're not the ones waiting for a spinner while it's being generated. So, $lookup is kind of meant to be used in scenarios where you're less sensitive to, slower execution time. Where'd the mic go? We had a question up here.
Question for you. We are upgrading from 4.2 to 6. We have an aggregation query with a group. Yeah, I know, boing, boing, boing.
A lot of versions.
We have an aggregation query with a group. In 4.2, it performs it, let's say, 1 second. When we run the same aggregate in 6, it's slower. The one thing we do know about it is it pulls a large document, which forces it to spool. So our assumption is,
You mean to spill to disk?
yeah, just spool to disk.
Okay.
So do you know, did something change from 4.2 to 6 with spooling?
No. With
Okay.
spilling, the only thing that changed is it'll actually log, so you'll know from the slow query log whether it's spilled to disk and how much disk it used. That's not going to make it slower. One thing I always tell people is when you're testing stuff in the new version, run it a bunch of times, because the first time it's always going to be slower. Right?
Yeah, and we've run multiple
Okay.
times, and we,
Yeah.
taken documents out, and it seems to be related to a large array inside.
Yeah.
And
I would open a support case.
okay.
Right, because this is the kind of thing that they can look at and probably with the better logging in 6, figure it out.
Okay.
And maybe there's a bug, right? In which case we'd want to fix it. That would be like first time we've ever had a bug, right?
Really?
Yeah.
We didn't have it more.
I know. I thought we had this new company value,
Yeah, we
no
said
more
bug
bugs,
free, no more bugs.
but
They're undocumented features.
undocumented feature, yeah. Question over there, and then another one over here.
Hi, thank you. Thanks for your time, and I really appreciate that. And this is like a very basic question that I have. So let's say if I am planning to, build a social networking site,
Yep.
and I'm choosing backend, and I'm going with a NoSQL. So let's say I come to you and I say, can I go for MongoDB as a POC? And then would you recommend that for us to use?
Absolutely.
And then what is the success use case that you have that you will back up your suggestion with?
I
For
mean, we literally wrote
Well, that's
an
going to be a long
implementation.
answer. Yeah.
Like Twitter, like for example, like Twitter like website,
Yeah,
social
yeah.
networking.
So
You
in
have many to
2000
many.
In 2014, our solution engineering team did a bunch of reference implementations for common use cases. One of them was called Socialite. The source code is still in GitHub. There are recordings out there of talks about the different components of it, the user graph, the content, how to build the timeline, right? Because the important thing in a social network is when a person logs in that they immediately see content. That's important. If they post something for their followers to see it instantly, that is not important, right? You go to Twitter, first, if we all go to Twitter, we're each going to see something completely different. And then when you refresh, it'll be completely different again because they just serve you whatever shows up first, right? So the important thing there is to know, what is most critical to the SLA and to structure the schema in such a way that as the amount of content increases, because people generally don't look at old content, your response time will stay the same because of right-balanced indexes. The reason I would tell you to use MongoDB is because the code already exists. You can literally just take it and, adapt it to your exact use cases. And we've had customers who have done that. And I personally, back in 2014, and then again a few years ago when we added transactions, benchmarked it, and on relatively modest hardware could emulate something that at the time it was meant to and did resemble about 10% of Twitter traffic in 2014, 2015. So it was pretty beefy. Obviously, it would probably need a lot more hardware now, because to emulate 10% of Twitter now, you'd need a lot more noise. You'd need a lot more bots, which amazingly, it has built-in benchmarking. So it's actually easy to benchmark exactly how much load it can handle. But my philosophy, I spent many years working with relational databases. My philosophy is most use cases you can use most databases, especially if you know them well and you understand where the rough edges are and where you need to really spend the time to optimize things. Hard-pressed to think of a database that you couldn't use relatively effectively for just about any use case, right? There are always a handful of very specialized edge cases, right, where a specialized engine will always outperform a general database. But, I know MongoDB really well now. I could probably use it for anything. But before that, I knew relational databases really well, and I did use them for anything, including things they were never meant to be used for.
Any failure where they moved away from the MongoDB because they couldn't scale in the social website? So
I'm sorry.
Do you know any example of a failure use case?
Oh, absolutely.
But they moved away from, in this case.
They've given talks. Right after I gave the Socialite talk at MongoDB World, we had a customer who gave a talk about how they tried to implement a social network. And he kept saying, if I'd seen that talk that was just right here before me, then we would have avoided these mistakes and we would have avoided those mistakes, right? And what are typical mistakes? For schema design, it's things like embedding followers into the user record, right? That seems like a great idea until you realize that if you have very popular users, we call it the tale of two Biebers, right? The Justin Bieber with 50 million followers, you can't have that embedded in a document, right? And you wouldn't really want to, because when they post, you never need to broadcast that to 50 million users. And if you did, you could just query for everybody who follows a particular user. So there are many mistakes that could be made. Would somebody need to migrate away from using MongoDB for this use case? If they made those mistakes, they wouldn't. They would just need to fix those mistakes, right?
And we can probably generalize to all the other workloads, or most of them. Yes, you can use nearly any database for any solution.
Yeah.
But if you had to use one that will cover most of the use case, I think we're in a very good seat right now with MongoDB. We've built a lot of things, in the last few years. So product, in the past, we would say, okay, it's good for document processing, but it's not as good for graph, it's not that good for search, but we've added all those functionality in it. And my favorite things with MongoDB, first, it's very easy on the developers. Your code, your documents that you see, the objects will match the code and what's in the database, and makes things so much simpler. We have a customer who migrated to MongoDB, and they slashed 200,000 lines of code and things like that. So, favorite thing, making the schema versioning pattern, be able to make updates on database without downtime. The cost of that is amazing. All of you who've been in the technology world for a long time, you know how expensive maintenance is. So if you have code that is simpler, and on top of that, you can do easy migration that's going to be clean, you're going to save a lot of money at the end of the day. I think we're trying to make the product just easier and better.
Having said that, you can write stupidly inefficient applications using MongoDB, just like you can write really inefficient applications using a relational database, right? It's just, especially 10 years ago when I joined Tengen and started working with MongoDB, when somebody would say, "Oh, my database is slow," and they'd be like, "What database?" MongoDB. "Oh, it's because it's terrible." And then, but if they said my relational database is slow, they'd say, well, don't you have indexes, right? And it's like, MongoDB is just a database. If you don't have indexes, it has to look at everything. That's slow, right? And so I actually, early on when I used to do admin training, I found that experienced relational DBAs always got it the fastest. They would just very quickly realize it's a database, it's exactly the same. The thing that's different is the data model. And so the problem are going to be the same too, which is developers who don't test their code, or they test their code on 40 megabytes of data and then toss it over to production and then say, hey, DBA, it's your problem that it's slow now. It's like, no, it's not. I guess we started a little late, so we'll probably only have time for one more question.
Yeah, we can sneak in one more.
Sneak
Thank
in
you.
one more.
Yes.
We had one up here. And we can always keep talking over drinks and stuff.
Hi, my question is mostly related on migration. Is that okay?
Sure.
Yeah, so in my company, right, MongoDB is an approved pattern for new applications. But for existing applications, it's a big no-no.
If it's not broke, don't fix it, right?
Okay, so basically, I initially architected the application with 20 plus microservices on Oracle database as an RDBMS database on-premise solution. And then when we were doing the Azure migration, I wanted to explore MongoDB, but then the amount of time it would actually take us to migrate from really RDBMS to
Existing.
MongoDB
Already
and also all of our
existing data, you mean?
services. Our management felt that the return on investment was not worth it. So
They may be right.
yeah, okay.
They may be right, right?
Yeah.
It's one of those things where, and this came up a lot, again, like 10 years ago. A lot of people were like, well, I want to use MongoDB for new projects because new projects require fast-moving data, fast-changing data, high velocity, right, variety, blah, 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 whatever. And then they would go to an existing application, which worked, and use a relational database. But then they would want to add some features to it that involved, integration with social networks, integration with other data coming in from elsewhere, and they'd be like, well, we can't cram this into a relational database. So they would leave the basic functionality in the relational database, but add the new functionality in MongoDB or some NoSQL document database. This way they didn't have to migrate stuff, and they didn't have to change existing code, but new functionality, they had the flexibility to use something that would work better for highly dynamic data, for highly variable type functionality. Maybe that's an approach that would work here. I mean, the fact is that migrations are painful, right? We're working on the relational migrator tool because it's such a pain in the you-know-what, right? But I think that if the fact that things are in this relational database are limiting things, right? You can't add new features. That's going to be a competitive disadvantage, right? That's going to be so. But the trade-off, nobody can tell. And even if I could tell you, I still couldn't sell your manager on it without them running their own calculation, right? Only you guys know how much you're risking losing in future business versus how much resources you would have to dedicate it to it. Then those are resources that are not working on new features, right? These are tough questions. There are no easy answers here.
It's a cost-benefit thing.
Yeah.
One of my favorite story, and I know there's a lot of you guys are probably from Cisco here, is a presentation that they did at MongoDB World a few years ago where they decided to tackle their main billing system, which was 50% of the revenues of their company. We're talking about a lot of money here. And they had so many problems with it, they said, we need to modernize that. And it was using Oracle. They went and migrated the thing to MongoDB. They slashed like 200,000 lines of code, something like that. And then that team threw the baby over the fence. Their operation team received it. And then we had a presentation from that operation team the following year in the following MongoDB World. And they talk about their experience. Well, they were able to do a ton of updates in the year. None of them with downtime. They said, we couldn't do that before. With Oracle, it was every downtime, every modification incurred downtime over the weekend. People were tired. And every time we were making a modification, sometimes we didn't do it cleanly because, it was too expensive to do it right. But with with the modification, the migration to MongoDB, they had a product that was much more cleaner. So it's just basically what you get. But there's a cost associated to it,
Yeah.
as Asya said, you know. And only you guys know the benefit you're going to get versus the cost of migrating the application.
40 seconds till happy hours.
All right.
All right.
First off, I want to thank Asya and Danielle for sharing all those amazing insights.